Let's talk about angle addition formulas. So what if we have a case where we want to find like sine of, what if we wanted to do sine of 75 degrees? What is that? Well, we know that's 75 degrees is 45 degrees plus 30 degrees. It would be nice if we could just say that's equal to sine of 45 degrees plus sine of 30 degrees, but unfortunately that's not the case. It doesn't simplify that easy. But it's not too complicated the way it actually works. So let's talk about that. So in general, if you've got an angle sine let's just say sine of x plus y, that's equal to sine of x cos y plus sine of y cos x. I'm just going to list out all the trig, all the angle addition formulas for all the trig functions. So cosine x plus y, that's equal to cosine x cosine y minus sine x sine y, and then tangent of x plus y equals tangent of x plus tangent of y all over 1 minus tan x tan y. So we'll talk about how to remember these in a second, but for now just let's carry this through. So sine of 75 degrees, let's carry that through using the formula. So that's equal to sine 45 degrees cos 30 degrees plus cos 40, or you can write it either way, but sorry, sine 30 degrees cos 45 degrees. So now sine of 45 degrees, that's root 2 over 2, cos 30 degrees, that's root 3 over 2, plus now sine of 30 degrees, that's 1/2, and then cos 45 degrees, that's root 2 over 2. So that's root 6 over 4 plus root 2 over 4. So that's root 6 plus root 2 over 4. So that's equal to sine 75 degrees. That's how you find it. If you wanted to find, like, let's box this off for a second. If you wanted to find sine of 15 degrees, well then you could just say that's sine of 45 degrees minus 30 degrees. And now it's the same kind of process, except now this becomes negative 30. So sine 45 cos negative 30 degrees plus sine 30 degrees cos, or this should be negative 30, cos 45 degrees. Now, cosine of negative 30 degrees, that's the same as cosine of 30 degrees, because either way, whether we're here or here, the x coordinate is still the same. It's right there. So you can just write sine 45 degrees, cos 30 degrees, and then the sine of negative 30 degrees, that flips sign, because the y-coordinate is different. The y-coordinate is negative there versus positive there. So we can just write minus sine of 30 degrees cos 45 degrees. If you don't like working with negative angles, that's how you can switch it out. Okay, and then we just do, that's root 2 over 2, that's root 2 over 2, that's 1/2, and that's root 3 over 2. So that is root 6 over 2 minus root 2 over 2, which is root 6 minus root 2 over, Yep, so that is equal to that. Yeah, it looks pretty similar, right? Except you're adding here, subtracting here. Yeah, so that's how you deal with minusing angles. You're subtracting angles. You just take the negative angle and carry it through, simplify however you want. So now let's talk about how to remember these formulas. So let's break it up into sine and cosine first. So with sine and cosine, I usually remember that sine keeps the same sign in here. Like the sign of adding angles keeps the same sign of the operation, keeps the same addition. Whereas cosine, like it turns plus here into minus here. So sine keeps the same sign, and cosine doesn't keep the same sign. And then sine switches the sine switches the usage of sine and cosine. So it's like sine cosine first, and then again sine cosine. So sine doesn't keep the same things together, but cosine does. So I view this cosine as an aspect of staying the same, and then like this plus as an aspect of staying the same. So each one has an aspect of staying the same. But sine keeps the same sign, whereas cosine keeps the same functions together. If that helps at all. For tangent, I find that one a little bit easier to remember because it's like we've just got a fraction, and the top is just what it would be really nice if tangent came out to, like tan x plus tan y. And then you just divide by 1 minus tan x tan y. So yeah, this part's really easy to remember, and then just don't forget to put that in the denominator. So there you go. That's how you work with addition and subtraction of angles within trig functions.